Hey folks, just thinking about a couple of videos I can upload, and today we're going to or I guess I don't know about today, but the weekend I guess, maybe today, we're going to build a couple of circuits. One of which I've got a couple of requests of how to build a power supply, a simple power supply. Basically, if for this one, it's going to be for electrolysis. That's going to be the purpose of the power supply. It's going to be a simple one, nothing to it. You got your AC cord, you got your fuse, switch, transformer, bridge rectifier, electrolytic capacitor, voltage regulator, and another cap. And this is a power supply, secondary, primary. There's your primary. There's your secondary over here. Output. That's basically. This was connected to this at one point, but I disconnected it because I want to do this video. I'm going to build the secondary part of the transformer or the power supply. I'm going to build it on a piece of perf board, project board, which is going to be mounted to these studs right here. It's going to be fused, switched, the whole works, just so you can see how a power supply is built from start to finish. Normally, this is what this board here was originally mounted here like that, and this was inside of an old speaker system I had that I no longer used, so I scrapped it down, got a couple parts out of it, and that was the actual power supply. But showing you this is one thing. It's already a completed circuit, but I'm going to show you how to build an actual circuit on a piece of perf board, as you can see here. Anyways, if you're interested in seeing this one, stay tuned, because that will be the first up, how to build a basic power supply for electrolysis. So throw that out, just out of the way. The second part, or the second video, we're going to build ourselves a computer to radio interface. So I can control my radio on my computer. Something I haven't done in a long time. I'd say close to 10 years since I've done digital, and most of the time my mic is hung up, and I like listening to some digital stuff every now and then. I actually had more fun with digital than I did on voice, so I think it's time to build myself a digital interface. So this circuit here is fully isolated, a couple transformers, an optocoupler. This one here is not fully isolated, although I built circuits like this before, use it on my Tentec Argosy 525 Delta, and never had any problems with it. The thing with this part is you got to have the two transformers and an optocoupler. That itself is, if you haven't got the parts, well, obviously you need to buy it off eBay and wait a month and a half for it to come, or you can get a bunch of parts and you can build this one if you haven't got patience. Personally, I haven't got the patience. So we're probably going to end up building this one. We're going to test it out and see how it works. If I got the parts here, I haven't looked, we'll build this one. But if we're not building this one, we're going with this one. But anyways, two of those are a computer to radio interface. It says to build it inside a steel case, metal enclosure. Well, you remember this thing I built many moons ago, and how they went before? Well, hell, it didn't turn out as well as I wanted it to. But I'm going to be taking everything out of this, gutting it, and we're going to build my computer interface into this enclosure instead. I have my LEDs here. I'm going to reutilize these with an IC that I have, an LED driver for audio, and we're going to see how well it's going to work. I use all these for my inputs, outputs, but anyway, let's see how that's going to work. But that's the second video. Anyways, stay tuned. It's going to be interesting. Okay, so we've got most of our parts here. Got to add heat sinks and everything else later, but for now we're going to work on getting the circuit board to line up with the 4 holes here. And basically all I done was take the board, slide it in here, like so. Line up the board with the holes like this, and just got a marker, permanent marker, and put it down in the holes. And then we have our 4 spots we're going to drill our holes and to mount the board to these standoffs. So, pop a few holes in the board, and then we're going to mount the board to the front of the transformer, like so. That's what we're doing first. Okay, so now we have the board mounted, screwed onto the transformer, copper side out, so we can solder to it. And now we have to mount our components. So we have a bridge rectifier here. We can either solder it on like that, or we can solder it so it's straight up and down. Or we can mount it like this and bend the tabs down. So there's a few different ways you can do it. But I think what I might do is actually put it maybe there. Actually, I can bend my tabs up, my legs, and we can mount it right there. So that's where I'm going to put my bridge rectifier. Well, flying ahead a few hours, we've yeah, I went ahead and pretty much built the thing. Yeah. No fuse, no switch. Yeah, I know. Should have a fuse. Should have a switch, but this is just to give you an idea, I guess, of anything. This is the power supply. It consists of a 15-volt regulator right here. That 15-volt input is getting its voltage directly from the bridge rectifier. Turn on the light here. There we go. So it turns off the getting power from the bridge to positive. Goes on over here to the input of the 7815. Center pin is ground, and then you have an output pin, which feeds the pin 3 of the LM317, which is the red wire over here. Then you got your center pin, which is the output, goes over to the capacitor here. I've got a little voltage kind of set up here, a voltage indicator, because I got her so I can adjust the voltage on this critter. That's just my voltage set. 2 caps, 1000 UF, 16 volt each, and yeah, that's pretty much it. So I guess now you want to see this thing in action, I suppose. The only thing you're actually going to see doing anything will be the needle here, and the meter will be going up or down depending on what way I move this. But let's have a wee peek and see what this thing does. So that's the needle, our meter. So we're going to plug this thing in. It'll be powered immediately. As you can see, that's full voltage there, which should be up to 14 volts. And then I'll just move the knob clockwise, and you can see that she brings her down to about 1 volt. That's just a S meter from an old CB radio. That's all that is. Move her up a little bit so you can see it, maybe. There you have it. Easy. Anyways, it's basically how you build a power supply. Not much to it really. But one thing, obviously you need your fuse and you need your switch. So right now, that's how she's set up. So we'll zoom out of here. So the output is right here. So we're going to see, I'm going to put her on the voltmeter and you can see the voltage going up. So we got the digital voltmeter hooked up to it right now. And I'm just adjusting the voltage. As you can see, it is indeed changing. Up to 14.06 volts. 2 volts under the voltage rating of the two electrolyte capacitors. You really don't want to exceed those guys. She may go snap, crackle, pop. Anyways, just give you an idea of how easy power supplies are to build. Not a whole lot to them really. But I guess the one thing I guess you're going to want to see is, can it actually power something? Is there enough current in this here power supply to power a radio? Well, let's see. Okay folks, so I've got the a chicken band radio hooked up here, CB. It's a old realistic Mini 23. And this one you give me there, Lauren, if you're watching. So yeah, we got her hooked up to that crazy power supply I got here. And yeah, let's see. She dims it a little bit. I don't know if you can see that or not. See if anybody come back from badness. Brake channel 4, brake. Control bad on this. Brake channel 4, brake. Minnesota. Anyways, let's take a look at the power supply here. So you're now looking at the meter at the power supply, and that radio is really got a bad something. But anyways, I'm going to key her up. Watch the red needle. So there is a bit of a draw. So let's take a peek and see how much of a voltage drop there is on the power supply. When there was no radio attached to it, we had a, as you can see, this would radio turned off, and this is what it turned on, and this is what it keyed up. So there is a voltage drop. So let's just see how much of a voltage drop. So that there's floating voltage on the power supply. That's with the radio not turned on. So right now we're going to turn the radio on and see how much voltage we drop just by turning it on. So we drop about 1.5 volts on from 14 to 12.6, 12.7. So now we're going to key the radio and see how much she drops. As you can see, 10.5. So you lose about 2 volts due to current draw on the power supply on key up. So again, radio turned off, radio turned on, and key up. So what we need now, or I guess the next project that we're going to be doing, there's actually a good power supply for this. we're going to come up with a circuit to increase the current capacity of the power supply. The transformer itself outputs, according to the label on it, 12.5 volts AC and 2.5 amps. Now, that's just transformer alone. That's not including all the rest of the circuitry that's attached to it, which is more or less where the voltage drop is coming from. So, in the next installment for this power supply, we're going to see if we can increase the current capacity of a power supply. Show you how it's done. Anyways, hope this video was somewhat useful. Again, I don't recommend ever building a power supply with no fuse or switch for obvious reasons. Anyways, hope you enjoyed the video, and we'll chat later. All the best, folks. We're out of here.